So they're asking, what is the what? What is the distance? D, distance. Now, do you guys know what formula this is again? What did we say yesterday? Didn't we see a little bit of this yesterday? So we're going to see a little bit more today. So we're going to go over this idea. This is the very famous distance formula. Like if you said to somebody, hey, have you ever been to San Diego? And what do they say? Yes. You go, okay, good, good. How long do, you'll say, how far is San Diego? How far, right? What do people say? Oh, 2 hours. Well, you can't say that because that's a unit of what? Time. So distance, ladies and gentlemen, traveled. How far? Distance traveled is D. Time, ladies and gentlemen, is T. What is R? What is R going to be? It's your rate. So distance is rate times time. We could measure how far something is by knowing the rate and multiplying it with the what? Time. So this is distance. How far? We're going to use this information today. So we're going to warm up with that simple calculation we did yesterday. And there's something going to say, what is the distance? Okay. And here's the 5 questions. So I'm going to change this to a colon. And notice this. What are they giving you? If a car is traveling at what? 50 miles per hour, what is that going to be? That's a rate. Do you guys agree with that? How do you know it's a rate? Because the units here, mph, this tells you that you're dealing with a rate called R. Okay, so here's the rate. And then, what else does it say, right? You're traveling for how long? For 2 hours. Okay. So if you're traveling for 2 hours, then what's the deal? This is a unit of what? Time. So they're asking for distance D when the rate is 50 and the time is 2. All right, you guys okay with that? There you go. There you go. Okay, so ladies and gentlemen, I'm going to give you guys some time to do this. Each one of these situations is very similar. You say, what do you mean it's very similar? Well, aren't they giving you, now a boat is traveling at what? 35 miles per hour. That's a rate. And then what? You're doing this for 1.5 hours. That's time. So each one of these has a rate and a what? And you're going to compute the distance. So ladies and gentlemen, I'm going to give you guys some time to do this. Okay, it shouldn't take that long, but this is our S portion, or supplement. This is kind of some information from beginning algebra. Anyway, we'll give you guys the nice lucky number 7 or 8. All right, we'll stick with 8. Who knows? Okay. Warm up with some beginning algebra. Okay, ladies and gentlemen, here you go. Distance equals what? Rate times time. So, what does that mean? Here, oh, it looks like we're not getting everything. Okay, that's fine. Okay. So here, D equals R times T. What is R here, ladies and gentlemen? It's the 50 miles per hour, and then let's make sure we get times the 2 hours. Is that true? Now, we could use our calculator, but I'm just going to use my what? My head. Okay, because what is 50 times 2? 100. So that's going to be in 100 what? Miles. Remember the units. MPH, miles per what? Hour. Okay? And then that's times hours. So the units cancel. I just want to make sure you guys understand that great detail here. So this is going to be in what we say 100 miles, because that's what MPH stands for. All right, you guys okay with that? What do you guys think? So if somebody ever says to you, hey, how far is Santa Barbara? You never give them time. You forgot the rate. You don't say, oh, 2.5 hours. No, no, no. That's not how far. Okay? Because the distance is not time. It's rate times time. Okay. All right, ladies and gentlemen. Now, yeah. Okay, so let's try the next one here. So you have now distance is rate times time. So notice every single time I use an equation, I write it down. So that'll be 35 times what? Times 1.5. So we're going to try to find what that is. Okay. Now, here, we could use our calculator. Is that right? And don't forget, rate is what? Green times orange. Green, what? Orange. So 35 times 1.5. 52.5. And again, what are the units going to be in this case? What are the units again? Miles. We actually seen that conversion already. So in this example, you're going how? 52.5 miles. Easy peasy lemon squeezy. Okay, doing a little bit of S this morning for you, because this is going to help you today. And again, they're going to ask you distance. Now, a plane is traveling how? 625 miles for 3 hours. So, ladies and gentlemen, what's that going to be? Say distance is rate times time. Is that true? So, 625 times what? 3. So 625 times 3. Let's see. What do we get now? 625 times what? 3 will give you what? 1,800 and what? 75. And again, the units are going to be what? In miles. All right. So does that make any sense? Okay, a distance formula. All right, let's try the next one. Now you have a car traveling at what? 70 miles per hour. Okay, that's going to be a rate again. Is that true? $70 miles per hour. That's mph. That's a rate. What's the time here? 1 hour. So we have rate time or distance is rate times time. So ladies and gentlemen, what's your rate? It's going to be 70 times 1. And what's 70 times 1? And again, this units are in miles. We've seen already what happened to the units. So ladies and gentlemen, here you go. Distance is 70 miles. Boat traveling. For what? We forgot the H here. Boats traveling 20 miles per hour. That's a rate again. And then 4.5 hours. What's that going to be? Do you guys know? This is a rate, and then this is a what? So we know distance is what? Rate times time. So 20 times 4.5. We get to use our calculator. So what will be 20 times 4.5, ladies and gentlemen? Is that 90? Did you see this as 90 again? Okay, so 90 what? Miles. So ladies and gentlemen, 90 what? Miles here. Okay, so here we go. Hold on. Anyway. Okay, so what I'd like to talk about now, just to kind of let you guys know, we're going to still deal with questions about law of cosines today. A few questions. But they have to do with what's known as really heading and bearing. That's really the same thing. So does anybody know there is a system that's used for what we described as a bearing here? Okay, so you want to know how to look at this. Here's the deal here, okay? Remember, north is up. Is that true? South is what? Down. Okay, what is to the right? Well, to the right is east, and to the left is west. Okay, you guys with me on that? So, all right. So this is going to be how we describe direction. So this bearing here describes direction, and we got to be more specific. It's direction in terms of an angle theta. You go, in terms of theta, yes, absolutely. I'm just looking at some things here, okay? So, all right, direction in terms of theta. So, for example, they're going to say to you, okay, where is north 20 degrees west? So they gave you that angle theta. Okay, so they're going to give you this angle, but they're going to give you instructions. So what they want you to know is this. They're going to always give you, now, this is done differently in some other countries, because I've been doing this for quite some time, and international students tell me in some other countries, they don't say northwest, but, you know, and I'm not sure which countries do a northwest, but read this left to right, okay? So if I say to you guys, north, where's north? So you start up here, north. Is that true? And then now, what angle did they say this is? 20. So how they measure this in terms of direction is this angle would be what? 20 degrees. This is how they measure. So they're communicating north 20. And why did I go to the west direction? Why do you think I said I went this direction? Because I need to know. Yeah, because if you read it left to right, they're saying start north and then slant 20 degrees how? West. And this is the direction that they are describing here. Okay? So this is the angle that you must use when they do that. All right, you guys okay with that? It's a very simple system, but it's not a 20-degree angle on like an x-axis, right? Positive x-axis. So you might say, well, what if they told me instead south 20 degrees west? And for this, you got to know what direction is south. Okay, do you guys know where south is? Well, south is down here, is that right? So you start south, and then 20 degrees in what direction? West. So they're saying this. You're moving in this direction here. Start south, okay? You're going southwest. You guys see what I'm saying? Southwest here. Oh, I like that. But where do they put the angle? The angle is here. This is under the idea of heading and bearing, okay? We're going to deal with law of cosines here. Yep. So if they said, okay, how about, for example, north 60 degrees east. North 60 degrees east. So let's see how we do this here. Northeast, northeast, northeast. Northeast, how many degrees? 60 degrees. So this is 60 degrees. So I need to know, let's see what color. We know north is what? Green. And then I guess we can say, I don't know, yellow would be east. So this is how we describe the direction. Okay, so I'm going to put that here. Heading and bearing. And then, to give you guys another example, they can say south maybe 75 degrees west. So, south, oh, let's do east, sorry. We already did southwest. East. So, ladies and gentlemen, we got to go southeast. You see this? Start with south, headed east. Start with south, head east. The bottom and the right. But what's the angle going to be now? 75 degrees, okay? So you say, well, where do they put that angle? The angle goes here. This is what? 75 degrees. Excuse me? They read it backwards. And there you go. What if I said to you guys, you know what direction, by the way? You know, they might say this in the future, just so you guys know. What if you travel due west? What do you think due west means? You're just going where? In that direction. You're just moving to the what? To the west. You're moving to the right. Oops. Thank you. Good job. And it's the wrong color. See how you get drawn to the color? So due west. Strictly to the what? Strictly to the left. What would due north be, you think? What color was that? Let's go to the color. Green. So due north, ladies and gentlemen, will be green. So this is kind of just some S here. Okay, it's going straight up. What do you think due south would look like? There's due south. Okay, and then due, you also have due east. Easy peasy, lemon what? Squeezy. All right, you guys okay with that? You guys see what we're saying? This is heading and bearing. So you might say to me, what does this have to do with law of cosines? You guys want to see what it has to do with law of cosines? Let's give you guys some law of cosines. Two boats leave the same what? Port. One boat travels at a speed of 30 miles per hour, and another boat travels at a speed of 50 miles per hour. How far apart? Oops, made a mistake. Let me do this. Speed 30 miles per hour. We've got to give you more information. I'm gonna move this out of the way. In the direction of 45 degrees east. Okay. Now it's going to be okay. And another boat travels at a speed of 50 miles per hour. In the direction of, south 20 degrees east. Okay, southeast. Now they're going to ask you what? How far apart? Okay, so we'll do this south 20 degrees east. How far apart are the boats? Okay, so here's a classic law of cosines question that's used in navigation. So, it's always good to show students how to use the math. This is the reason why you study it. You just don't do exercises if you're not going to use it, right? Okay, I'll give you guys some time to copy that down, and I can draw you a picture. And you might say, well, how does that picture even look? Let's draw a picture here. So essentially, I'm going to draw that same compass. North, what? South, east, and what? West. Oh, how far apart are the boats in 2 hours? Oops. Yep. There we go. Okay, so here's what I'm going to do here. This, ladies and gentlemen, is where the port is. See that dot? You put it in the middle of your compass. Okay? And then now you have 2 boats. Is that true? One boat, what's the story with one boat? It says one boat travels at a speed of 60 miles per hour in this direction, north 45 east. Okay, you guys okay with that? North 45 east. So what I'm going to do here is, it's a northeast situation. So northeast. So here's my line. I'm going to do a line here. North what? Northeast. What's the angle though? 45. So we got to know it's about a 45-degree angle. So I'm just going to draw this line here, okay? And I'm going to label this to be 45 degrees. This is for that boat, that first boat in orange. I'm reading. I'm highlighting the words. Another boat travels at a what? Travels at a speed of 50 miles per hour in the direction south 20 degrees east. Southeast now. So, ladies and gentlemen, Southeast. What was the angle? What was it? 20. So 20 degrees is kind of a much smaller angle. Is that right? So label that what? 20 degrees here. Now, I just drew straight lines here. Okay, I'm getting an idea of the direction because guess what else I have to notice how to do? What do you guys think? What are they asking for? How far apart are the boats in 2 hours? They didn't give me any distance, did they? So they gave me a rate and they gave me a what? Time. Good. So what do I know about distance? It's rate times time, don't you think? This is why we warmed up with that. But the problem is they didn't tell me like boat A and boat B. They were vague. One boat, another boat. So I'm going to let the orange, the first one, be A. What's the rate here? 30. What's the time? Do you guys know what the time is? 2 hours later. So I'm going to take 30 times 2, and what does that give me? Isn't that going to be what? 60. So what I'm going to do now is I'm going to try to draw a distance. I'm going to call what? This distance is 60. That's my A, just so you guys know. Okay, so that A distance is 60. What's the other boat? The other boat is what? Let's call the other boat B. What's the rate for the second boat? Well, the rate is what? 50. What's the time again? Is that 20? So this would be 50, or 2, sorry. What's 50 times 2? So this is in miles. So B is longer. Maybe I'll make it really long like that. And that measures how much? 100. And that's my B. So you might say, why are you labeling it B and the other one A? Well, because now it's a little bit more familiar to you guys. If I just connect now these locations, I see I have a triangle. Is that true? And that's the how far apart the boats are. That is the distance called D. And that's what they're asking for. How far apart are these boats? So why am I calling this a law of sines situation? Does anybody know? Why is this law of sines? What kind of situation is this? Well, you might say, I'm going to make the claim. This is side, angle, side. And you go, really? I have side, angle, side? No, I don't. Do I have an angle between two sides? Well, I have to find out what that angle is. The angle's right there. How do I get that angle? Does anybody know? How do you get that angle? Well, let's call this theta, right? So isn't it true 45 degrees plus theta plus 20 degrees is 180? How do you guys know that relationship? How do you guys know that's true? Doesn't this form a line? Isn't that a line there? Even though I drew a circle for a line. What I mean by that is the 45-degree angle plus the angle we need plus that 20 degrees needs to be 180 because that's a straight line. When you add those three angles, you get a straight angle. A straight angle measures 180. So really what we end up saying is this. The angle theta is found by taking 180 minus 45 degrees minus 20 degrees. So what is that going to give you? That's going to be what? 180 minus what? 45 minus what? 20. And that gives you 115 degrees. Okay. There it is, ladies and gentlemen. This is what I say. You have a what? Side angle side situation. This is what makes this a law of what? Law of cosines question. This is law of cosines. You got an angle, and it's in the between two adjacent sides. We can now find very easily the opposite side. Now, you say, how do we do that? This is law of cosines, right? The opposite side to that angle is the square of the two other sides, A and B, minus double the A and B, cosine the angle between the two sides. That's the side angle side situation here. So A is 60, B is 100, and let me change the colors. Might be easier to see. A is 60, B is 100, A is 60, B is 100, and the angle is 115 degrees. So your d squared will be that 60 squared plus 100 squared minus 2 times 60 times 100 times cosine 115 degrees. So what would d become then? $60 squared plus 100 squared minus 2 times 60 times 100 times the cosine of 100 and what? 15 degrees. Is that right? Have you guys seen all this detail before? Yes, yes, yes. So this is a law of cosines kind of question. So, okay. All right, let's see. Here we go. I'm going to clear everything out if I can. Second square root 60 squared plus 100 squared minus 2 times 60 times 100 times cosine of what? 115 degrees. What do you guys get here? 136 point what? Let's go to the tenths. 6. What did you guys just find? This is distance. Is that true? They are 136.6 miles apart. And that's the law of cosines question they want you to answer. So we went through all the details here for this, ladies and gentlemen. This is a classic. It's a very classic kind of questioning for law of cosines. It's very classic. What's that? Oh yeah, please do. Close that door. There's a weird negative. It's called negative pressure. I don't know what the deal is. I don't know how they fix it. Anybody know anything about buildings? I want to Google up how do you get negative pressure in a building, and then how do you get rid of it? You might think it's a ghost, and it's not. Maybe it is a ghost. You guys think it's a ghost? It's Halloween. Anyway, and I want you guys to do let's give you guys another great kind of question here. It's a lot easier than what we just did, though. Let's give you another question that they have. Calculating distance, we did something like that. They can even say this. A car travels along a straight road. Now, let me double check here. Heading east for 1 what? Hour. It then travels for 30 minutes in a northeast direction. If the car maintains a constant speed of 60 miles per hour, how far is the car from the starting point? Okay, so we're going to have to draw you guys a picture on this so you guys can see what's going on. Okay, so here's kind of what they're saying here, okay? You have a starting point, I guess, here, and notice you're traveling how? East, is that right? So there you are, you travel east. And you travel there for 1 hour. So I'm just going to put time here is 1 hour. And what happened after the hour? Do you guys know what happened after that 1 hour? It went in the northeast direction. Is that true? And what's the time here? 1/2 of an hour. Is that true? You guys okay with that? Now, I'm going to draw the triangle here because they want to know how far is the car from the starting point. They want to know a distance. How far? How far is the car from that starting point? Okay? So let me say this to you guys here. This is kind of something that they should have said to you. They're going to travel north, east, a 45-degree angle. Okay? So what I like to do is I like to put a little compass here, north, east, and this has to be what? 45 degrees, okay? So I put a little compass a lot of times because I think it's actually what's happening in the situation. And this is a 90-degree angle, is that right? Okay, for a compass. Now I'm going to make the claim again that this is a side angle, side situation. I'm also going to label the bottom distance A and this northeast distance B. So I want to label those. Maybe it's good to have some color so you guys can see that. So this distance will be what? A, and then this distance will be what? B. All right, you guys okay with that? Could you guys tell me what the distances are going to be? What is A going to be? I need that distance. I still need a rate for A. I have a time. For B, I need a rate. I have a time. The time for A is 1, and the time for B is 1/2. Is that true? But what's the rate? How do you guys know the rate? What's the rate here? Is it 60 miles per hour? So for both of them it's 60? Yeah. $60 times 1 is what? 60. That's 60 miles. 60 times 1/2. What's that going to be? 30 miles. So A is 60. B is what? 30. But does anybody want to tell me? Here's the thing, though. What's the angle between them? I need an angle between them if this is side angle side, don't you think? It's not 45 degrees. What's it going to be? It's 135 degrees. How do you guys know it's a 135? How do you guys know that that angle has to be 135 degrees? Because you take the 90, the right angle, and you add it with what? 45. Is that true? Anyway, I just want to point that out. This is law of what again? Law of cosine. So, d squared again is what? A squared plus b squared minus 2ab cosine d, where a is 60, b is 30. So I'm going to change colors. 60, 30. 60, 30. Cosine the angle, that's 115 degrees. So here's what you end up with. D squared is what? 60 squared plus 30 squared minus 2 times 60 times 30 times cosine of 115 degrees. And then d is going to equal, take that square root, 60 squared plus 30 squared minus 2 times 60 times 30 times cosine 100 and what? 15 degrees. That's how you find the distance d. Side angle side. So again, in your calculators, we say, okay, here we go. Clear that out. Second square root. 60 squared plus what? 30 squared minus 2 times what? 60 times what? Times 30 times cosine 115 what? Degrees. What is the distance? 77.6 what? Miles. Yes. Yeah. How do we get this? See if I could go back and erase this. For the compass, for the direction northeast, to say northeast, we didn't define it for you, like saying due east. Northeast is that 45-degree angle. If they're vague and they didn't give you an angle, like in this question, so I drew the compass. Would you agree with me that I drew that this angle is correct? But for your triangle, that is really not the angle there. Is that true? Now, these lines intersect these lines are perpendicular. That means there's a square there. Maybe I got to change the color. That means this here is a 90-degree angle, that corner there. Okay, you guys okay with that? So that blue angle is found by taking what? The 90-degree angle and adding it with the what? 45. And what do you end up getting? That's how this angle at this vertice is 100 and what? 35. Because we took 90 degrees plus what? 45 degrees. Okay? It's 135 right in there. Easy peasy lemon squeezy. Oh, I'm sorry. Did I put 115? Oh, did I put 115? I apologize. I'm not even awake. I put whatever somebody told me. Oh, somebody told me 115. I said, okay, 115. Oh, let's do that again. Yeah, I forgot my coffee when I left the house there. And my wife even brought it. Isn't that nice of her? Sorry, 135. Did it again. I'm just thinking of my wife. She brought me some what? She brought me my coffee. But you want to know something? I don't think she gives me this whole thing, and there's just a little coffee in it. It is the thought, but the woman doesn't understand volume. This is a true story. She doesn't understand volume. Like, you had a birthday party where there was probably at least 60 people. And she orders a birthday cake that's this small. I think so. But she meant it for everyone else. And so I'm like, I had to call her. I said, listen, I don't think the cake you ordered is going to have to serve 60 people. So I had to order another. I ordered two. That's still not going to serve 60. I was just like, I'm not going to argue. They did. They sell them. There's like Amy's Bakery over here in Montebello. If you guys go to Amy's, so you got that nice cake, 2 of them, and this is a true story. So as you're singing "Happy Birthday" to the little baby girl, that one cake she ordered, she put it on this special thing. It fell on the floor. I got video of it, I think. As I'm videotaping. It fell on the floor. And I'm like, oh my God. So I just said, go get the other cake. She went inside, she got the other cake. Everybody thought she was a genius. Like, oh my God, the woman is so organized, she had a backup cake. And I'm like, I'm not going to say. They didn't know it was really who? Me, who got the extra cake, because the don't understand volume. And there are people like that. There are people like that. Anybody here like that? You guys know what I mean? You'd say there's 100 people in the room. You're going to have to serve pizza to 100 people, and you go get a little one. You guys know what I mean? You can't do that. You got to understand volume. This is this is why science is so important too. Understand volume. Don't give me a big flask when for I don't know, a quarter of it is with coffee. So every morning, I got to go to the Husky store and get more coffee. You have to take her and sit her down in a science class. That's why you guys take math and science serious. So that way you can order cake and pizza and not be... Anybody ever get embarrassed? You just order too little and you're like, I don't know what happened. No, you guys don't? And then there's some people, you know what they do? They just order too much. They go, I'm going to cover my bases and order like 500 pizzas. When only you need what? I don't know, 4? Do a count. Do some thinking. Do some critical thinking. Okay. How many slices come in the extra large? Okay. I don't know, 8 slices. And if I have 5 people and they each eat 3 slices, that's 15. I could get 2 large. You guys know what I mean? Anyway. All that because I made a mistake. 135. Okay. Do we do that in the calculator? No. 115. Okay, let's get rid of that. Huh? Yeah, I don't really use calculators, I hate to say it. I mean, I could have edited it. Is there an undo button here? You could go back up there even after you hit enter? Really? After you hit enter? Let's try it. Let's do this. 60 squared plus what? There we go. Does that look okay to you guys? 60, 30 minus 2, 60 to the cosine 130. Okay, that's about 83.9 miles, right? It could be if you went to the whole number. It could be. But what we've been doing is distance to the nearest tenths, angles to the nearest whole number. So that distance is 83 point what? 9, looks like. Yeah. That's the distance, 83.9 miles in this one. So thank you for finding that error. I wasn't even awake. I wrote down what people did. All right. Now, I want people to note something here.